Guys, I finally bought my very own 3D printer to use on the channel for all of my personal projects. So in today's video, I'm going to unbox it, get it set up, and start its very first test print. If you're a returning viewer or subscriber, thank you so much for your continued support on the channel. I greatly appreciate it. And if you're a new viewer, welcome. I hope you guys enjoyed this video. And if you like what you see, definitely consider subscribing and checking out some of the other content I have on my channel. I do all sorts of videos related to my go-kart project, my car projects, just automotive related content in general. And now I'll be doing a ton of 3D printing related videos as well. Now, I've been involved with 3D printing for probably about 5 or 6 years now, ever since my good friend Will introduced me to it back in undergraduate engineering school when I was at UC Irvine. And since then, I've been involved in a number of 3D printing projects over the years of college, both undergrad and in graduate school. I actually did my master's level thesis in 3D printing with conductive polymers. And since then, since I've graduated and moved on to a full-time engineering position, I'm now doing a lot of 3D printing projects there as well as a manufacturing/industrial engineer. I work for a company that overhauls and repairs rotary and fixed-wing aircraft for the Navy and Marines. So there's a lot of opportunities for me to create custom 3D printed tools, jigs, fixtures, and sometimes even parts for these aircraft to help speed up the repair process. So over the years, I've gained a ton of knowledge and experience with 3D printing, and I've really wanted to apply it to my personal projects that I do on the channel here and at home related to the go-kart, the vet cart, and just a bunch of other things. So I'm really excited to have a 3D printer of my own to really dive into learning the nitty-gritty parts of 3D printing and applying it to all the different projects I have, because there's a remarkable amount of materials that you can use for a number of different applications now. So needless to say, I'm excited. I'm excited to start making videos on it and sharing my knowledge with you guys, because it's a really cool technology that's been evolving very fast and is very up and coming for manufacturing to come in the future. So I'm going to stop talking now. I'm going to go over to the printer. We're going to unbox it. I'm going to explain really briefly of why I chose this printer, and then I'll take it out, get it set up, and we'll start the very first test print. So here's the 3D printer that I purchased. It is a Creality CR10s. Now, there were a number of 3D printers that I was considering buying before looking for this one, and there's a ton out there. You have a lot of options to choose from if you're looking for a 3D printer, but there were a few main reasons why I went with Creality and specifically the CR10s. The first being, this printer is relatively cheap. There are printers that you can buy for your desktop use at home range from very cheap to also very expensive. This one is very affordable. It was right about $400 on sale for their Black Friday deal. So that was the first reason. It's pretty affordable. The second reason being, it's a very popular 3D printer. There are tons of videos, support forums, and a big community that supports this 3D printer and the Creality brand in general, which would help greatly for troubleshooting and just different ideas and mods to come in the future. The third reason being is that this printer has a fairly large print volume and print bed size. It's about a square foot, and then it goes up a foot, so you got 1 cubic foot of build space approximately. So it'll allow me to print some larger parts for the car build, the go-kart build, and stuff like that. And the fourth real big reason why I bought this printer was because it is very upgradable. There are tons of parts that you can buy from Creality or from third-party manufacturers to upgrade and make this printer print with really high quality, high grade materials that are high strength to use for automotive applications. And there's tons of parts to upgrade on this to improve reliability and just overall print quality. So that was the main reason why I went with this Creality printer. So I'm going to go ahead and start unboxing now and show you guys what comes in the package. So this here is our base plate. Put this on the table. I can use this packing foam as a maybe shadow foam for my toolbox. Little box here. This is probably like accessories and tools and stuff like that. I'll put that to the side for now. Okay, it looks like we've got our power supply or screen here and central brains to the printer. Alright, so I got everything out of the box. Got our Z-axis tower there. build plate there, central like motherboard screen there, and then we got our accessory box. But again, packaging really nice and firm and secure. They do a good job at putting lots of foam in there so it doesn't jiggle around and possibly get damaged. So good to see that from the get-go. Here's the accessory box. So this looks to be the orange like striping that you can get for the Creality CR10. It usually comes in blue, orange, or in this case what I got because they only had that in stock. And then if you don't put this in, the printer's black. So I'm probably just gonna leave this stuff out because I like the black look. So we got here is a little tool bag with some hex wrenches, you know, open end wrench, some zip ties, and something. Let's see what's in this little cardboard piece here. Oh, this is our like cutters. So these will help with breaking off support material, cutting filament, stuff like that. So it's nice to include a little tool bag with the printer because those specific Allen wrenches that go with the printer. Here we got a USB cable so we can directly connect the computer to the printer. So this looks to be like an instruction book. So I'll use this when I go through assembling it, user manual and everything like that. This is just a quality control certificate. Let's see. Got some extra nozzles here, another spare bolt, some spare bolts, spare nuts, stuff like that. A nozzle, a little brass piece where the filament or the Teflon tube goes through. Got a scraper, power cord, filament holder spool, and then this is the bracket for it. Some more Teflon tube. I think it came with some. Yeah, it comes with some, but they give you a spare one. Nice, got a little USB stick. And then these are probably the brackets to mount the Z tower. Another kind of bracket or something here. I think this is for end stop. And oh, and then we get a little sample 200-gram spool of PLA. They give us white PLA as a sample test spool, so that's nice. We can, because I did order a kilogram spool, but it hasn't gotten here yet, so we can start with this stuff. So that is everything that comes in the box, and now I'm gonna go ahead and start getting it all put together. So the next thing I'm gonna do here is the Z tower comes with a lot of these zip ties on it to hold it in place during shipping, which is also a nice thing to see as well. So I'm gonna go ahead and snip these guys so we can prep it to get mounted. Okay, so this part was a little challenging, especially as just one person, but so putting the Z-axis tower on, it's just 4 bolts on the bottom of the XY plate here, but it's just getting it to sit like this and then putting it on. So what I kind of did was I balanced the Z tower this way, and then just held this up to get 1 bolt in, and then once I got 1 bolt in, it kind of wanted to stay in place. But other than that, it's just 4 bolts and the Z tower comes into place. So it'll definitely help if you had an extra set of hands, but it's definitely doable with 1 person. Alrighty, so the next step after you do that is you got to put these little brackets on. So this T-shaped one goes on the right side if you're facing the front of the printer, and then this one over here, which is still a T-shaped one, but it's got this extra bracket on for the end stop control. This goes on this side. So it's got these special little nuts that go in between the rails here that they'll go in 90, and then once you screw them tight, they kind of pull and secure it snug in place. So it's an extra brace for the Z height or Z tower. In addition, it holds the end stop for the Z axis as well. So I'm going to go ahead and do that next. Okay, so we got the spool holder mounted on like the main motherboard housing. So the next step is to connect all our wires to the respective locations, and Creality makes it nice and simple here because they put these little yellow tags on. I know you probably can't read that, but it tells you on each of these little yellow tags what stepper driver motor it needs to get plugged into for the right location. So that will be very helpful. So I'm going to do that next. Alrighty, so I'm almost done getting all the stepper motors and axis sensors all plugged in. The one thing I wanted to clarify is the CR10s, this extra sheet here that's separate from the normal instruction assembly manual, this is for your filament runout sensor, since this is an add-on here. So this piece that you saw come in the packaging, this is your filament runout sensor, and it's got a little slit in the bracket, so it literally just slides on right next to your extruder motor like such. It's kind of hard to do this one with one hand, just like that, and it'll kind of seat in place. And then what you have to do is the one lone wire that comes with this. So this is the filament runout sensor cord that goes to the main motherboard. The cord itself comes with a plug, or it's like a short already on it. So right now we could take the filament runout sensor off and it would print just fine. But if you want to plug this into the actual sensor here, you have to take off this little circuit like short board here, and then you can actually plug it in. Because if you want to use it without it, you just leave it in this configuration, and I would recommend maybe keeping this guy in case you don't want to use the runout sensor in the future. So this is what your filament runout sensor will look like with the cord plugged in. So now I've got that finished. So the last kind of like 3 pieces here related to wiring is you got to plug in the kind of like an aircraft grade connector here. So this is for the heater for the extruder or the hot end, and then you have the same type of connector for the bed, the heated bed. And you'll know there's 2 ports here, you'll know which one is for which. The one port has 4 prongs, the lower one. The top one has 7, I believe. So this one here for the bed is the 4, so that'll go on the bottom. And then this one here is the 7, and then you just plug it in, and it's got a little screw there that you secure it down to the box with. So once we do that, and then I plug in the main power cord to the wall, we can fire this guy up for the first time. But I think what I'm going to do before I do that is just clean up some of these wires, which is why they provide you that packet of zip ties so you can make this look as clean as possible. Okay, so I think I got all of the necessary plugs plugged into the right stepper motors and extruders and axis limit switches. At least we'll find out. And then I tried to do a little bit of cable management back here. You see, got quite a few cables running around, but I didn't want to zip tie them all down just yet until I figure out which cables need the most room when the printer maxes out at its height limit and whatnot, because I didn't want to limit any cables based on their travel. So got the final power cord plugged in. The only thing too that they say is switch depending if you're at 230 or 115. We're at 115. So let's go ahead and flip on the main power switch. Alright, so we're at the main home screen here, so I'm going to go ahead and start kind of getting some of these setup procedures done, such as leveling the build plate and whatnot, and just testing, make sure our stepper motors are all working okay by manually moving them. And then once I do that, I'll do a quick brief run through of leveling the build plate, but I'll save a lot of that stuff for my review of this, and then throw some filament on and we'll get our first test print going. So let's just test our different axis steppers here. Okay, we got our X. Cool, we got our Y. Got our Z. Alright, so I tested a few more things. Everything looks good. I heated up the hot end to PLA temp, and then I tested the extruder because that's got a feature in it where if it knows the hot end isn't hot enough, it's not going to try and extrude and shove cold filament through the nozzle. So that's all good. I cleaned up some of the wires because I had them all, a few of them tangled up because I raised the Z up to close to its limit, and I had some wires intertangled within each other. So this is going to be a little bit of a work in progress to figure out better cable management, because I don't really like how this looks right now, but that'll be for future to come. So right now what I'm going to do is level the bed, and then from there I'll get the software on my computer and we can get ready for our first print. So one thing that is common in 3D printing, if you're not too familiar with it, is something called bed leveling. So that's just essentially making sure that the bed is level in all four corners. So I like the CR10s because they have these really ergonomic scroll wheels on here that make it really easy to adjust the bed. A lot of printers will also have an automatic bed leveling with a sensor next to the extruder. That'll do it for you, but honestly I just don't mind leveling it myself because sometimes it's a little bit better that way. So basically what you do is you go into the software here. I know it's kind of hard to see the screen. Let's see if I can adjust. It's a little blurry, but bear with me. Go to prepare, and then you go to bed. Even though it says auto leveling, you're not auto leveling anything. So you just click next step, and then it moves the extruder to the four corners where you need to level the bed from. And then what you do is at each corner you take usually just a piece of paper. Some people prefer an actual shim, but then you just go in there and you shim it so that there's a little bit of resistance between the paper and the nozzle. And you do that for all four corners, and then you should be good to go. Okay, so what I did next was actually just download the Creality specific slicer software. Normally I use Cura, but it turns out that the Creality slicer uses Cura as the backbone for the software. The interface is pretty much identical to Cura. So now I'm going to go ahead and get my test print set up. I got my CR10s build plate. It's like when you first set it up, it asks you what printer you're using. So this is the build volume of our CR10s. So what I'm going to do next is go to Thingiverse. I always like to do the 3D benchy little boat as my test calibration print. You can see it's a very popular test print. And then I'll go ahead and get this loaded up and we will start printing it. So here's the little 3D benchy test print boat that I was talking about. It's a great little torture test, like a mini torture test that doesn't eat through a ton of filament. This is one of many different types of torture tests you can do with 3D printers, which basically tests all the capabilities and functions and how well it's performing. And you can do this a lot when you're running different filaments, you're trying a new filament, or you're just getting a printer set up for the first time. Alright, so we got our little benchy boat loaded in here. Got the layer height. I know you guys probably can't see those settings very well. Layer height at 0.1, shell thickness 1.2, enabling retraction. Print speed 50, we'll keep it nice and slow. Print temp 200, bed temp 40, support type we're going to do no support for this. We're going to enable a brim for the adhesion type. We got 1.75 diameter filament, nozzle size 0.4. So looking good. I'll export this to our little, oh, that's another thing that I want to show you guys, is that so Creality actually provides you a I thought this was just a standard flash drive, but what it is it's actually a USB drive adapter for a micro SD, which is pretty cool because this is what the printer takes, are these micro SDs. So this allows you to easily transfer from your computer. So you can either use this or an SD, like a micro SD to large SD adapter. But the USB is nice too in case your computer doesn't have a SD card slot. Okay, so we got our first test print going here. I set it up once and it started running, and then the brim started peeling up. I don't know if I have the bed temp set at 50. I know you guys can't really see that very well. And then I have the extruder temp at 200. So I know different people with different printers run PLA at different temps, but we'll try this. So what I did in the meantime was I just put a glue stick down to help with adhesion, and so far it's been working pretty good. And it seems like our bed level is at a good set distance right now. So this thing has got, I think it's about a 3-hour print, and we'll see how this thing goes, and I'll keep you updated throughout the process here, and then once it finishes. Alright guys, so we're about 30% done with the print. Everything's looking good. The layers are looking nice. So this first test print is going pretty well so far. So I'll keep you guys updated as things progress, but our little benchy boat's looking pretty good. Okay, so a little update. It is now the next morning. I've since tried 2 prints here, and you can see we've been a little unsuccessful, but I figured it was not to be without a few bumps in the road when setting this printer up initially. So I've been doing the 3D benchy boat as I discussed earlier. This is the first one, and you can see this one got pretty much like 95% of the way there, and then the print popped off the bed, shifted, and made this little rat's nest. Then I tried it again, just thinking maybe that was a fluke, and this one actually failed probably halfway through, did the same thing. So there's a lot of talks, and this is again the reason why I got this printer. There's a lot of talks online and forums about how to get better bed adhesion, especially with PLA. So I think what I'm going to do, I did try and put a little bit of glue stick down the first time, and then the second time I tried the hairspray. So those are the 2 things I tried. But the thing I'm going to try next probably is getting some mirror tiles, because I think what I noticed was the 4 corners were pretty level, but there was a little bit of a low spot in the middle of the glass. And I'm not trying to make this video about troubleshooting. This is just kind of like an initial setup, but I thought it would be nice to end the video with a successful test / calibration print. So I'm going to go to IKEA actually and get these mirror tiles, and then it's a pack of 4, so I'll experiment, and some people even sanded them and roughed them up to rough the surface up to help with adhesion, and some people just left it as is. And the theory is that mirror glass, because you can't have any distortions or else it won't reflect, you know, as a mirror properly, it should be very straight and very level. So I'm going to try that along with maybe roughing up the surface, and we'll see how we do there. Okay, so another quick update for you guys. So I went ahead and went to IKEA yesterday and actually bought these mirror plates. So it's a pack of 4. The actual product's called Lots. But before I tried this, I think after talking with my friend Will, who's a guru with 3D printing, he recommended just trying the typical blue tape, and I have used this trick before to see if that helps with bed adhesion. So I just got some 3M blue painter's masking tape, put it over the bed, re-leveled the bed, and so now we're gonna get this print going and we'll see how it does. So I'll keep you guys updated throughout the print. Alrighty everyone, so 3rd time was a charm. So we got our completed 3D benchy test print. So it seems that the masking tape, the blue tape, really helped with adhesion here. I haven't, the print just finished. It took a total of almost 4 hours, 3 hours, 48 minutes. I had it printing a little bit slower, and I had the infill density up a little bit higher, but I haven't even tried to break it off yet. But let's just see how strong it is. Oh yeah, it's stuck on there pretty good. So pretty crazy how much just adding some blue tape on top of the glass bed could help. But this thing turned out pretty darn well. Pretty happy with it for the very first, well, 3rd print of the 2 failed ones, but of our first successful test print on the CR10s. Alright everyone, that's going to do it for this video on unboxing and setting up my CR10s 3D printer. I also did a little bit of troubleshooting in order to successfully get my first 3D Benchy test print done. So I do plan on doing a lot more 3D printing videos in the future and adding that as a big part of the channel and sharing my knowledge with 3D printing with all of you, because it is definitely a very popular and up and coming hobby and technology. So thank you all very much for watching this video. I hope you guys enjoyed it. If you did, hit that subscribe button if you haven't already. And other than that, I will see you guys in the next one.